Testing games thoroughly involves a comprehensive strategy that ensures a game functions as intended, provides a positive user experience, and is free of critical bugs or performance issues. Below is a detailed guide on how to conduct thorough testing of games. 1. Understanding game testing categories. A. Functional testing ensures the game works as expected based on its design and specifications. Common areas tested: game mechanics, character movement, interactions, abilities, level progression and objectives, game rules and how they are enforced, win/lose conditions and how the game responds to them. Menu navigation, start screen, settings, pause menu. Input responsiveness, controller, keyboard, mouse, or touch. B. Performance testing verifies the game's performance under different conditions and load. Common performance tests include: frame rate ensures smooth gameplay with a consistent FPS, frames per second. Latency tests for input lag or network lag in multiplayer games. Memory usage monitors how much memory the game consumes and checks for memory leaks. CPU and GPU utilization verifies how efficiently the game uses system resources. Stress testing pushes the game to extreme limits to ensure it handles heavy loads, e.g., multiple players, large numbers of assets on screen. Load time checks how quickly the game loads levels, screens, and assets. C. Compatibility testing ensures the game runs properly on various platforms, devices, and configurations. Areas to test: different operating systems, Windows, Mac, Linux. Console variations: Xbox, PlayStation, Nintendo Switch. Mobile platforms: iOS, Android, multiple devices and screen resolutions. Different hardware configurations: graphics cards, CPUs, RAM. Input methods: game controllers, keyboards, touchscreens. D. Security testing protects the game from hacking, cheating, and other malicious behavior. Focus areas include: data security, verifying encryption of sensitive player information, such as payment details or personal data. Cheat prevention ensures that cheat codes, hacks, or exploits cannot bypass intended game mechanics. Piracy protection tests the game's mechanisms to prevent unauthorized distribution, e.g., DRM. Network security ensures secure communication between servers and clients, especially in multiplayer environments. E. Localization testing ensures the game works correctly in different languages and regions. Areas to test: translation of text, menus, and dialogue. Adherence to local legal and cultural standards. Correct display of region-specific content, e. G. Currencies, time formats. F. Usability testing verifies that the game provides an enjoyable and intuitive user experience. Focus areas, UI/UX testing ensures user interfaces are easy to navigate, with clear icons and instructions. Player feedback collects data on how players experience the game, e.g., difficulty, engagement, emotional response. Accessibility ensures the game is accessible to players with disabilities, e.g., colorblind modes, closed captions, custom control mappings. G. Multiplayer and networking testing tests features that involve multiple players interacting simultaneously. Key areas to test: server load testing ensures servers can handle large numbers of players and maintain stability. Matchmaking verifies that players are matched correctly based on skill level or other parameters. Synchronization ensures that actions performed by one player are reflected accurately in all connected sessions. Network latency ensures smooth gameplay even under high latency conditions. H. Compliance testing ensures the game adheres to platform-specific guidelines and standards, e.g., Sony, Microsoft, Apple, Google. Examples of compliance requirements: controller input handling for console games. Platform-specific achievements or trophies. Store page compliance with platform guidelines. Rating board requirements, e.g., ESRB, PEGI. I. Exploratory testing conducted by testers without following predefined test cases, aiming to uncover unexpected issues by freely exploring the game. This form of testing often reveals boundary or edge case bugs, unintended interactions between game mechanics, issues related to creativity in gameplay, e.g., using in-game physics to bypass obstacles. 2. Test planning. A. Define a test plan. Create a detailed test plan that outlines testing objectives. Scope of testing: what will be tested and what will not. Responsibilities and roles. Test schedule and deadlines. Resource requirements: hardware, tools, testers. B. Create a comprehensive test matrix. A test matrix should include all the test cases and scenarios. Areas to cover: game mechanics and interactions. Different difficulty levels or game modes. Hardware configurations and compatibility. Edge cases, e.g., max number of players, minimum/maximum settings. 3. Creating effective test cases. A. Functional test cases include test cases that cover every aspect of the game mechanics, ensuring that all characters and objects behave as expected. Game rules are consistently enforced. Different game modes work properly. B. Performance test cases include specific tests for different frame rates and resolutions. Monitoring CPU, GPU, and memory usage. Measuring response time for network interactions in multiplayer games. C. Negative test cases. Test the game under unexpected conditions, such as incorrect or invalid input from players. Server downtime or disconnection during multiplayer games. Exceeding allowed limits, e.g., jumping out of map boundaries. D. Edge case scenarios. Explore how the game handles unusual conditions such as player actions that might not be anticipated by developers, e.g., skipping certain levels or missions. Abnormal character behavior, e.g., pressing multiple buttons simultaneously. 4. Automation in game testing. A. Use automation for repetitive tests. Automated tests can be used for regression testing to ensure that changes do not break existing features. Performance testing. Automated tools can measure frame rates, CPU, GPU usage, etc. Stress testing. Simulate thousands of concurrent players in multiplayer games. B. Limitations of automation. While automation is useful, it is less effective for usability and experience testing. Exploratory testing, as it requires creative thinking. Visual and aesthetic testing. Human input is needed to judge the quality of graphics, animations, etc. C. Tools for automation. Some popular automation tools for game testing include Selenium, UI automation for web-based games. Appium, mobile game testing. Unreal Engine automation tools. Unity Test Framework for testing Unity-based games. 5. Specialized game testing tools. A. Performance monitoring tools, FRAPs, measures FPS and takes screenshots to evaluate visual quality. NVIDIA Insight offers GPU profiling and debugging. Profiler, Unity/Unreal Engine integrated tools to monitor CPU, GPU, memory usage. B. Bug tracking tools, Jira, for bug tracking and project management. Bugzilla, tracks issues and defects in-game. MantisBT, another bug tracking system used in game development. C. Network simulation tools, Clumsy, simulates network problems, latency, packet loss, etc. NetLimiter, controls and monitors network traffic to simulate different conditions for multiplayer games. 6. Common bugs in game testing. A. Physics bugs, unusual or unrealistic behavior of characters or objects, e.g., floating, clipping through walls. B. UI/UX issues, misaligned buttons, text overflow, or elements not responding to clicks/taps. C. Animation glitches, characters or objects moving erratically or failing to animate properly. D. Audio issues, missing or out-of-sync audio, or distorted sound effects. E. Collision bugs, characters or objects not colliding properly with each other or the environment. 7. Post-launch testing and maintenance. A. Patching and updates. Post-launch testing ensures patches and updates don't introduce new bugs. Regression testing is crucial after any update to check that older issues don't reappear. B. User feedback monitoring. Collect and analyze user feedback from forums, social media, and support tickets to identify issues that may not have surfaced during testing. 8. Best practices in game testing. A. Test early and often. Early testing catches bugs before they become harder to fix. Continuous testing during development is key. B. Balance manual and automated testing. Use automation for repetitive tasks but rely on manual testing for areas like gameplay mechanics and visual elements. C. Cross-team communication. Effective communication between developers, designers, and testers ensures that bugs are resolved quickly and test cases are aligned with the latest game design updates. D. User-centered testing. Testing should always account for the player's perspective. Make sure the game is fun, intuitive, and immersive. By incorporating a well-rounded game testing approach, covering both technical and user experience aspects, you can ensure that a game launches in a polished, bug-free state while offering a seamless and enjoyable experience for players across different platforms and devices.